Number 29, letter A. Use of hydrogen fusion to supply energy is a dream that may be realized in the next century. Fusion would be a relatively clean and almost limitless supply of energy, as can be seen from table 7.1. To illustrate this, calculate how many years the present energy needs of the world could be supplied by 1/1,000,000th of the ocean's hydrogen fusion energy. All right, so I picked out two pieces of information from that table over here on the upper right-hand side. And here's if we were to take all the oceans and fuse, right, essentially all the hydrogen in them, it would produce 10 to the 34 joules. All right, this column is in joules of energy, and the annual world energy use is about 4 times 10 to the 20 joules. So let's first, in order to answer the question, let's first take these pieces of information and convert them into ratios or fractions. All right, so first let me focus on the first one. So I can rewrite this information in fractional form like this. I could say something like 10 to the 34, okay, joules per all the hydrogen in the Earth's ocean, right? So I could say I'll just say H in Earth's ocean, okay? So all the hydrogen in Earth's ocean would produce 10 to the 34 joules worth of energy. The second category here, I can rewrite that to be 4 times 10 to the 20 joules, right, per year, right? That would be the amount, this is the amount of energy to supply world energy use at today's rates per year, okay? So now let's take a look at what the question is asking us to calculate, right? So it says calculate how many years, all right, the present energy needs of the world could be supplied by 1/1,000,000th of the ocean's hydrogen fusion energy, all right? So essentially what I have to do there is I have to convert that information into, fractional form, all right, or create a ratio out of it. So I want to know how many years, right, essentially I want to know how many years, right, supplied by per 1/1,000,000th, all right, of the hydrogen fusion energy. Okay, so I need to find this unit, years per hydrogen fusion energy or in the Earth's oceans, right? So this is really the unit I want to find. So my job now, I don't like that part on the Y there. Let me make that a little neater. So my job now is to try to figure out how to manipulate these two ratios so that when I multiply them together, okay, I get this ratio. All right, that's my job. So first thing I notice is years are on the top here, and I notice years are in the denominator here. So what I want to do is I want to flip this fraction, okay? So I'm going to put 1 year over 4 times 10 to the 20 joules. Okay, so I got years in the right spot. Now I notice I'm going to focus on the hydrogen fusion energy in the Earth's oceans. I realize I need that in the denominator. Here I have it right in the numerator. Excuse me, it's also in the denominator. What am I talking about? I was thinking about switching colors at the same time, that's why. So again, it's in the denominator here. It is also in the denominator in this ratio, therefore I'm going to leave it alone. All right, I'm not going to flip it, I'm just going to plug it in as I see it. So this is 10 to the 34, right, joules per all the hydrogen fusion energy in Earth's oceans. And notice the beautiful thing here. What happens to the joules, guys? Joules are here, joules are here, and look, they cancel, right? And you're left with year per hydrogen fusion energy in the Earth's oceans, which is exactly what we wanted. Now, the only thing is, right, they wanted to know supplied by 1/1,000,000th, all right, of the ocean's hydrogen fusion energy, okay? So essentially what I have to do is I have to add this last factor in, all right, and I have to divide my answer by 1/1,000,000th, by 1,000,000, not a millionth, but I have to divide it by 1,000,000, all right? So I find 1/1,000,000th the value of what it should be, all right? So this would be over 1,000,000 now, all right? So there's no units there because it's just a simple numerical division. And notice though, my units would still work out, okay? So let's find that value. So let's do 10 raised to the 34 and divide that by 4 times 10 to the 20th, and then take that result and divide that by 1 million. Okay, so we get a value now of 2.5, right, times 10. Let's count here. So we got 3, 7. Okay, so that's, yeah, so 10 to the 7th. So this is 25 million, all right? So this would be 25 or 2.5 times 10 to the 7, or 25 million years. Okay, million years per millionth, essentially, of the hydrogen fusion energy of Earth's oceans. Okay, this would be the answer. All right, so that's quite a long time. I mean, we're talking 25 million years. And then part B says, how does this compare historically with significant events such as stable economic systems? I mean, if we just compare them to, you know, let's just empires of, right, ancient times or medieval times or whatever. I mean, you're talking about what the Holy Roman Empire was about 800 years, right, 850 or so. Byzantine Empire was almost 900. Ancient Roman Empire was like 400 or 500 years, right? This value would be 2.5 times 10 to the 7, aka 25 million years. All right, it would last us. And that's only 1 millionth of the energy that would be inherent in the ocean. So it's quite a long time. So guys, thanks so much for tuning in. Please remember to subscribe, and I look forward to helping you with the next question. Take care.